Quick, graph y equals 2 times the natural log of x minus 3 by hand, two different ways. This is part of the family of functions series. You will need graph paper, or you can download this PDF and print it. Press pause as needed anytime during this video. Let's decide what the parent function is and its shape. Parent function is y equals the natural log of x, and it's shaped like this. Looks like an easy chair kind of dumping you out. Keep in mind it also has a vertical asymptote, and that the natural log and e to the x are inverses of each other, which means we interchange the x and y coordinates. Identify the parameters. These are values in the expression that affect the graph. In this case, we have two parameters. And how do they affect the graph? Well, the minus 3 shifts all y values down, and the 2 in front there multiplies each y value by 2. Neither parameter affects the vertical asymptote at x equals 0, so let's go ahead and plot that. The origin, however, is affected by the minus 3. The new origin will be at 0, -3. We're going to call this the new origin, and all points will be plotted relative to this new origin. So now we're ready to do the natural log of x dance. Again, remind you that natural log and e to the x are inverses of each other, and we need to know these four powers of e here. Normally it's right 1 up 0, and in this case it will be right 1 up 0. The x's aren't affected, and the y value is multiplied by 2, but 2 times 0 is 0. Normally it's right e up 1. In this case it's going to be right e up 2. We're going to double all the y values. Again, e is about 2.7. Normally right e squared up 2. In this case, it will be right e squared up 4, and e squared is about 7.4. Normally right e to the -1 down 1. In this case, it will be right e to the -1 down 2, and the reciprocal of e is about 0.4. And finally, right e to the -2 down 2. That will be right e to the -2 down 4, doubling the y value. Remember, e to the -2 means the reciprocal of e squared, which is about 14/100ths. So over 14/100ths and down 2 from that so-called new origin. We're ready to connect the points, and we get this natural log looking curve. Comparing it to the parent function, you can see it is shifted down in a little bit different shape. Let's look at a second way using a table. Again, recall the natural log and e to the x are inverses. These are the powers of e we need to know. And so these are 5 ordered pairs from the natural log of x that we will use. The 2 multiplies each y value by 2, and the minus 3 subtracts 3 from each y value. Notice that the x values are not affected, so we'll keep the x values the same. And by the order of operations, we multiply first and then subtract. So we'll multiply by 2 and then subtract 3. So 2 times 2 is 4, minus 3 is 1. We show that calculation over here. And then we'll plot 7.4, 1. Keep in mind you can pause anytime during the video. 1 times 2 is 2, minus 3 is -1. So we'll plot e -1, 2.7, -1. 0 times 2 is 0, minus 3 is -3. So 1, -3. 2 times -1, -2 minus 3 is -5. So 0.4, -5. And doubling -2, we get -4 minus 3 is -7. 0.14, -7. We can see there's going to be an asymptote here. The curve is flattening out here along the y-axis. So we'll draw in x equals 0 as our boundary line. Connect the points, and we get that natural log looking curve. and we like to compare it to the parent function. Now you try one. Graph y equals 1/2 times the natural log of x plus 4. Use either method or both for the practice. Press pause to do this and resume when you're finished to check. And here's your answer in green, and I've included a table in green and also the parent function.